This is half past paper week 11. This is the foundation tier. We've got all the odd numbers this week. This is a calculator paper. Here are all the topics that we'll be doing today, rounding integers and so on, how many marks they're worth, and the Sparks codes. As always, if you are a Sparks school, you can use those to look up more questions of the same kind. Okay, question number 1. Write 478 to the nearest 100. So if we're rounding to the nearest 100, this is our hundreds column, the 4, but we always check the next number. And if the next number is 5 and above, we round up. 4 and below, we round down. So the 7 is telling us to round up, and that's going to make the 4 into a 5. So we're closer to 500 than we are to 400. Change 1.5 kilometres into metres. So I always find for these questions that I need to write down something that I know is true. I know 1,000 metres is 1 kilometre. So if I'm going from metres to kilometres, I would be dividing by 1,000. And if I'm going from kilometres into metres, I'm timesing by 1,000. So 1.5 times by 1,000 is 1,500. Question number 5, write 19% as a fraction. So percent means out of 100. It means 19 out of 100. So 19% is 19 out of 100. Can't simplify that fraction. Even if you could, you wouldn't need to. Question number 7. There are 4 types of counter in a bag. The table shows the number of each type of counter in the bag. There are more green counters than red. How many more? So our green counters are here, 26 and 7. And our red counters are here, 16 and 11. Should have probably done those in the right colour, shouldn't I? There we go. So our green ones, we've got 26 and we've got 7. And altogether, that makes 33 green counters. With the red, I've got 16 and I've got 11. And that adds up to 27. Therefore, how many more green counters have we got? We would do 33, take away 27, which is 6. Question number 9, 4e add 6f, add 7e minus f. Now you might find it helpful on these questions to circle your like terms. So I've got 4e's, add 7e. The symbol in front, the add or the minus in front, is important. If you've got 4e's and you add 7 more e's, you're going to get 11e. Now let's look at our f's. I've got positive 6f, take away 1f. So 6f, take away an f, is 5f. And then people always get confused whether they should make that a positive or a negative. Well, we've got positive 6 and we've taken away 1, which has got us to 5f, positive 5f. So since this is a positive number, I'm going to write my final answer on the answer line as 11e add 5f, because that 5f is positive. If the 5f, if that answer had gone into the negative, then we would have needed to have written a minus in front of it, but it's positive. So 11e add 5f. Can't put those together and make it 16 because they're not like terms. We can only add e's with e's and f's with f's. Question number 11. The table shows the cost of sending a parcel by the express service and by the rapid service. Brendan has to send 12 parcels. It will be cheaper to send the parcels by express than by rapid. How much cheaper? So he's got 12 parcels to send. So we know that with the express service, each parcel is going to cost £15.25 to send. So we're going to do 12 times 15.25. This is a calculator paper, so we can just type that in our calculator. 12 times 15.25 is £183 to send those 12 parcels. With the rapid service, it's costing a little bit more. We need to do 12 parcels times £35.38. So 12 times 35.38 is going to be £424 and £424.56. How much cheaper is it to use the express service? So now we just want the difference between those two things. £424.56, take away 183. Now I might just do this non-calculator just to show you the method. 6 take 5 is 6, 5 take 0 is 5, 4 take 3 is 1, 2 take away 8. Now, if there's more on the floor when you're taking away, we need to borrow from next door. So that becomes a 3, and this is 12. 12 take 8 is 4, and 3 take 1 is 2. So it is £241.56 cheaper. Luke wants to send 21 parcels by the express service. He does the calculation 20 times 15 equals 300 to estimate the cost. Explain why Luke's calculation shows the actual cost will be more than 300. So the express cost is actually £15.25. That's how much it actually costs. And he said, well, let's roughly just call that 15. He's actually sending 21 parcels, and his estimation is to send 20 because that's easier to work out in his head. So he's rounded both values down, and because we're multiplying them together, that's going to make our overall answer too small. So he has rounded both values down. If you only make reference to one of the values, you're not going to get full marks there. So he's rounded both values down, which is why the answer is too small overall. Question number 13. The first term of a sequence of numbers is 24. The term rule is to add 8. Josie says no number in this sequence is in the 5 times table. Give an example to show that Josie is wrong. So all we need to do is keep going until we find one that is in the 5 times table. So if we add 8, that's 32. And if we add another 8, we get 40. There we go. 40 is in the 5 times table. So 40 is going to go on our answer line. It's in the sequence if we add 8 each time, and it's also in the 5 times table. Is 85 a number in the sequence? Give a reason for your answer. Now, there's a couple of ways that you could do this. The easiest way is probably just to keep going until you get there. So 24, 32, 40, 48, 56, 64, 72, 80, and 88. That's the easiest way to show. So we'll just say no, 80 and 88 are in the sequence, but 85 is not. You must go one below and one above if you're going to do it that way. Show that it goes past it and it doesn't get there. It wouldn't be enough to just get to 80. You need to say 80, 88. No, look, we've missed it. Okay, question number 15. You can use this rule to work out the total hire charge in pounds for hiring a 3D printer for a number of weeks. The total cost is the number of weeks times 70, add on 50. Mia wants to hire a 3D printer for 4 weeks. Work out the total hire charge. So it's going to cost her the number of weeks, which is 4, times by 70, add 50. Now be careful here because this is bid maths as always, so we want to make sure that we do the multiplication part first. 4 times 70 is 280, and then when we add on 50, that means the total cost of her hiring is going to be £330. Zahir hires a 3D printer. The total hire charge is 680. How many weeks did he have it for? So 680 is the number of weeks times 70, add on the extra £50. So the first thing I'm going to do is take off that £50. 680, take away 50 is 630. So how many lots of 70 is that? Now to find that out, we're going to do 630 divided by 70, and that is 9. So it must be 9 weeks that he's hiring the printer for. Question number 17. The accurate scale diagram shows a telephone mast and a box. The box has a real width of 1.5 metres. Find an estimate for the real height in metres of the telephone mast. So what we want to do is use our ruler. Now mine might be slightly different to yours. I'm doing it on my iPad screen as I'm filming this. So on mine, I'm going to make it slightly bigger just so I can. It's 2 centimetres. There you go. It's about 2 centimetres on there. It's going to be much easier for you to do. So on mine, that is 2 centimetres. So I can say every 2 centimetres is 1.5 metres in real life. Yours might be slightly different scale. Should be about the same. And then all you're going to do is measure your mast. I'm just putting my ruler on top. And when I measure this, it's 12 centimetres. Okay, so yours might be different. Let's see how big yours is. But whatever it is, it should be 6 times bigger. Whatever you've got for the size of the box and whatever you've got for the size of the mast, we can see that 6 of those would fit going up. So therefore, if this is 1.5 metres and I want to know how tall that telephone mast is in real life, I'm going to do 1.5 times by 6, and that is 9 metres tall. So a telephone mast in real life would be 9 metres tall. Oh, don't need the M, they've put metres there for me. Question number 19, make X the subject of the formula. So when we're changing the subject of the formula, same as solving an equation, I want to put a dotted line where the equals is. And what you do to one side, you're going to do to the other. To make X the subject of the formula means to get the X on its own and everything else on the other side of the equation. At the minute, on this equation, Y is the subject of the formula because the Y is on its own and everything else is on the other side. I'm going to start by taking 4 away from both sides. So that leaves me with Y take away 4 on the left equals 2 lots of X. I'm then going to get that X on its own. Now at the minute, I've got 2 lots of X. I don't want 2 lots of X, I just want X. So I'm going to divide this side by 2, but then I also need to divide this side by 2. So X is all we'd be left with on this side, which is what we wanted to happen. And on the left-hand side, to divide it all by 2, I'm going to put all divided by 2. And that would be your answer. So X equals Y minus 4, all divided by 2. Question number 21. Liz goes on holiday to South Africa. Liz wants to change £850 into South African rand. She wants to get as many 200 rand notes as possible. The exchange rate is £1 is 18.53 rand. Work out the greatest number of 200 rand notes that Liz can get for 850. So we know that if we want to change her money from pounds into rands, we are going to multiply by 18.53. Similarly, if we were going from rands back to pounds, we would divide by 18.53. So I'm going to take £850 and multiply it by 18.53. In my calculator, this is a calculator paper, so 850 times 18.53, and that gives me 15,750 rand, 0.5. I'm not sure what half a rand is called. You'll have to forgive me. There we go. So that's how much rand she can get. Now, she wants them in 200 rand notes. So how many 200s fit into that? So I'm going to divide by 200 to see how many 200s fit in. And that is 78.7525. Now, exchange rate places, the post office, whatever, they're not going to say, oh, we'll just round that up and give you extra money. They're not going to do that. So we want the greatest number of 200 rand notes she can get. It's going to just be 78. Even though that does round up, they're not going to round it up because that would be giving you extra money. So 78 would be the answer, and then she'd have to get some smaller notes or smaller change for the rest. Okay, question number 23. Costco sells packs of mints to shop owners. On Monday, 3 shop owners buy mints from Costco. Each shop owner buys small packets, medium packets, and large packets of mints. Alan buys 400 packets of mints. 32% of them are small and 40% of them are large. Okay, let's start with Alan then. So Alan has bought 400 packets. 32% of them are small. Now, the easiest way to do 32% in your calculator is to do 400 times 0.32. That is 32% as a decimal. So I'm just going to type 400 times 0.32, and that gets me straight to 32%. That is 128 small packets. 40% are large. So I'm going to take 400 and times it by 0.40, or just 0.4. 400 times 0.4 gets me 160 large. So the rest of his mints must be the medium ones. So let's do 128, add 160, and take that away from 400. And that gives me 112. So you must have 112 medium, because that's the rest to add it up to make 400. Okay, next, Beryl. Beryl buys 500 packets of mints. 3/10 are small. So we're going to do 3/10 of 500. Now remember, we divide by the bottom and times by the top. So 500 divided by 10 is 50, and 50 times 3 is 150. Or in your calculator, if you want to do that in your calculator, you can times instead of. So you can just write 3/10 times 500, and that would get you that same answer. So that's small. 1/10 are large packets. 1/10 of 500, again, divide by the bottom times by the top. That's just going to be 50 large. And the rest of hers must be medium. This adds up to 200. So there must be 300 more because we know she bought 500 in total. So 300 medium for Beryl. Great. We've now got Charlie to worry about. So Charlie buys 150 small packets, such that the number of small packets to the number of medium packets is in the ratio 3:4. Now this is where, if you watch my videos lots, you'll know I like to use these little hangman lines. 1, 2, 3, 1, 2, 3, 4. This is the small packets, and this is the large packets. No, medium. Read the question, sorry. Small on the left and medium on the right. Now we're told that he buys 150 small packets. That's given to us there. So I therefore know that these 3 lines have to make 150. And that means I've got 50 packets on each of the lines. 50, 50, 50, 50, 50, 50, and 50. Therefore, he must have 200 medium packets. Work out the total number of medium packets of mints these shop owners buy. You must show all your working. So we know that Charlie bought 200 medium. We know that Alan bought 112 medium. And we know that Beryl bought 300 medium. 300 add 112 add 200 is 612 mints, medium mints. So 612 is my I'm still in highlighter. 612 is my final answer, and that was for doing 112, add 200, add 300. Lots of marks available there, 5 marks for lots of different skills. These 3 skills, sharing in a ratio, fractions of amount, finding percentages of numbers, come up every single year. So if any of those are a little bit confusing, make sure that is something that you work on. 612 is your final answer. Well done if you got that. Question number 25. Katie invests £200,000 in a savings account for 4 years. The account pays compound interest at a rate of 1.5% per annum. Calculate the total amount of interest Katie will get at the end of the 4 years. So compound interest normally comes up more on the higher paper, but it is on foundation here. We've got 200,000 in a savings account for 4 years. Now, interest is extra money the bank give you as a little thank you for having your money with them. It's like an incentive to use their bank. You always get to keep 100% of your money, of course, and you get an extra 1.5% per annum, which means like annual, means per year, for having your money in that bank. So therefore, altogether, each year, we're going to get 101.5% of what we had the previous year. Now, we just saw in the previous question that to get a percentage, you can turn it into a decimal and times by that. So if I turn this into a decimal, it would be 1.015. To go from a percentage to a decimal, you divide by 100. 100% is 1, so 101.5% is 1.015. So I'm going to multiply by 1.015. And then we'd need to times it by 1.015 for the second year, and then times it by 1.015 for the third year, and then times it by 1.015 for the fourth year. So altogether we can just say that's to the power of 4 because we're doing this for 4 years. Typing that in your calculator, 200,000 times 1.015 to the power of 4. And now is where we really need to carefully read the question, because a lot of students missed the 7101, but it's money, so I'm going to just do 2 decimal places. Check the next number. Yeah, that rounds down. So £212,272, 71 pence. But it didn't ask you how much money is now in her account. It said calculate the total amount of interest. So we actually now need to take the 200,000 that she originally put in back off. So therefore, in total, the total amount of interest that she got was 12,272 £272.71. You would have lost a mark for not doing that final step. All about checking the question, reading the question, making sure you're doing what they're asking of you. Question number 27. Now, this was quite a tricky one. Sean has drawn a time series graph to show the numbers in thousands of visitors to a fun park. The number of visitors in thousands here on the y-axis, so this is going up. Now, I remember marking this one back in 2019, and a lot of students said, oh, they didn't put thousands on the axes. That's okay, there's nothing wrong with that. It clearly says thousands here, so that's okay, we're okay with that. The thing that you needed to spot is said write down 2 things that are wrong or misleading with the graph. Now, this graph is talking about number of visitors to a fun park in thousands. We've got 2016, we've got 2017, and we've got 2018. And the numbers, the 2, the 3, and the 4, we can assume that they relate to the quarters of the year. So the first quarter of the year, the second quarter of the year, the third quarter of the year, the fourth quarter of the year. And consistently, there is no one. I mean, I would assume, we don't know, that the theme park maybe wasn't open from January to March, maybe, or from December to February, or those kind of winter months, and that's why there's no data for the first part of the year. But we don't know that. We want to look more at bigger things that are wrong with it. I will read you all of the different answers from the mark scheme. There's quite a lot of options on there. The biggest thing I can spot that's wrong is that it goes 6, 6.57, 7.58, 8.59, and then 10. So the first thing I'm going to say is 9.5 is missing from the y-axis. I'm going to be really clear about where I'm expecting to see it. I'm expecting to see it here, well, where the 10 is really, and it's not there, so that's not right. It has to be a linear scale on each of the axes, okay? The other thing, let me read through these. The other thing they would have allowed is that the y-axis did not start at 0. So let's put that y-axis did not start at 0. It starts at 6. They allowed that. So let me read through all the reasons. You were allowed, the first quarter is not shown, plotted or labelled. It does not show all 4 seasons. You were allowed 9.5 is missing from the vertical axes. You were allowed the vertical axis does not start at 0, or the y-axis does not start at 0. The graph does not begin at 0 was okay. It's not clear what 2, 3 and 4 on the x-axis mean. You were allowed to say that. The scale of years does not make sense. You were allowed to say that. And you were allowed to say there is a lack of clarity about what the numbers on the x-axis represent. So those 2, 3, 4, it doesn't really say what they are. We're assuming they're quarters of the year, but we don't really know. Okay, it was not acceptable to say 0 is missing, because we wouldn't have expected the x-axis to start from 0 anyway, so you needed to say the y-axis to get that mark. It wasn't acceptable to say they shouldn't have connected the dots like that. It wasn't acceptable to say the numbers on the x-axis are repeated. It wasn't okay to say the numbers along the x-axis 2, 3, 4 and not say anything else about it. The years on the x-axis have not been written properly. That wasn't allowed. It does not follow a sequence. That wasn't allowed. It needs a discontinuity wiggle on the axis. So they mean this thing. That didn't get you a mark. And no title. You wouldn't believe how many students say to me no title. Also, the one I saw a lot when I was marking was about the thousands like that. You weren't allowed that either. So there we go. That was 2 things wrong with it, but ultimately not the loveliest graph. But always check your axis, what it's going up in. This is your y-axis, this is your x-axis, and make reference to those when you're talking through your answer. Okay, question number 29. Jeremy has to cover 3 tanks completely with paint. Each tank is in the shape of a cylinder with a top and a bottom. The tank has a diameter of 1.6 and a height of 1.8. Jeremy has 7 tins of paint. Each tin of paint covers 5 metres squared. Has Jeremy got enough paint to cover completely the 3 tanks? You must show how you get your answer. So I think it's going to be helpful if we roll this out. So we are painting the outside of this. So I'm going to unroll it to see the net of it, because I think that's going to help a lot of people to visualise what we're doing. Now the area of the circle is pi times the radius squared. So we need to do pi times the radius squared for the top of the cylinder and pi times the radius squared for the bottom. We know that this is the height of a cylinder, which is 1.8. But this distance along here, how would I get that? Well, that is the same as the distance around the edge of the circle, so the circumference. And we get the circumference by doing pi times diameter. So taking all that into consideration, the circle on the top is going to be pi times 0.8 squared. 0.8 because we're only going to the middle for the radius. If it's 1.6 all the way across, it's 0.8 to the middle. And then pi times 0.8 squared for the bottom as well. So we've got that one to do, and we've got that one to do. For the rectangle, I want to do pi times diameter, which is pi times 1.6, times by 1.8. And timesing all of that together is going to get me the area of that rectangle. So let's start with pi times 0.8 squared. And that is 2.010619298. Notice I'm writing lots of decimal places here. I don't want to round anything until I get to the end. And I've got the same for the bottom circle, 2.010619298. I also want to do pi times 1.6 times 1.8. That's the area of the rectangle. Pi times 1.6 times 1.8 is 9.047786842. So these three values added together are going to get me the total surface area of each cylinder. Adding all of those values together, I get 13.06902544. Now that's the surface area of one cylinder, but I want the surface area of 3 cylinders, so I'm going to times that answer by 3. It says in the question that he's got 3 tanks to cover in paint. So I'm going to times that answer by 3, and that is 39.2070763. Now, each tin of paint covers 5 metres squared. So he's got 7 tins of paint. So 7 tins of paint, 5 metres squared, means that 7 times 5, he can cover 35 metres squared. But our tanks are 39.2. The question is, has Jeremy got enough paint to completely cover the 3 tanks? And the answer is no, he does not have enough. Great, and you could even say 35 is less than 39.2 if you really wanted. There we go. That was for 5 marks, that last question. Surface area of a cylinder was the topic. I hope you found that helpful. Let me know in the comments if you had any questions at all. I'd be more than happy to help. And I will see you next week for week 12.